And it works for all polynomials. And that's really an important thing to realize. No matter what I throw at you, no matter how I twist the problem, no matter what I do, this always works. Okay, it always, always works. The next technique that we're going to teach you tomorrow doesn't always work. This technique always works. Note the result of dividing the dividend by the divisor is called the quotient. Now, these are kind of like grown-up words, higher level words for basic words that you know and love. This is the same thing that we would call the numerator. This is the denominator. This is what we would call the answer. So this is the higher level set of words that relate to these basic terms that we taught you ages ago. Can you say vocabulary questions on quizzes and tests? Okay, so be prepared. Okay? And, you know, when we did our division ages ago, you know, sometimes it worked out perfectly, right? But sometimes you got a remainder. Sometimes you got a remainder. And we are going to write our dividend. Okay, we have to write basically the numerator in standard form. That means it has to be written in descending terms. So if I give you a bunch of them and they're all mixed up, you find the biggest one and it's first. By the biggest, I mean the power, right? The highest power is first. So maybe it's x to the 5. Then would be x to the 4, x to the 3, x to the 2, x to the 1. And if I am missing any of those, let's say I don't have an x to the 4 in the sequence. I need to fill with a coefficient of 0 in that particular term. And that's going to be a key, and you're going to see me hit that pretty heavy in one of the examples over here. So let's start with what we do know. Example 1. You know, this was 107 divides into 87637. We know how to do that, right? We took 107 and divided it into the first 3 numbers. Let's see, that's going to go in 8 times. And when we did 8 times 107, I got 856. Then what did I do? We subtracted, didn't I? I'm going to put that in a different color. I would subtract, and when I do, I get 20. Then what did we do? We would bring down the 3, right? So I will bring down the 3. So now I divide 107 into 203. That's going to go in 1 time. And once again, I'm going to subtract, and I will get 96. I will bring down the 7, and I will go in 9 times. For 963, and again I will subtract, and I will end up with a remainder of 4. So how did we write a final answer if the teacher says, okay, so what's your answer? Your answer became, when you did the division, 819, and I'm going to write this now as a fraction. 4 divided by 107. Now that's the kind of format we're going to use. we're going to write any remainders back as fractions. All right, so that's what we do know, right? That's what we do know. The good old long division that we had hoped had gone away is not gone. And now we're back. Now, in example 2, you see a polynomial in the numerator. You see a polynomial in the denominator. I'm going to start by setting the problem up the same way we just did. It's going to be x plus 3 on the outside and x squared plus 5x minus 7 on the inside. Now, division is going to work exactly like you would kind of think it does. I'm going to start with this x on the x plus 3. What do I need to multiply that x by to get x squared? So up above the line will go an x. Now think of this as a division, or excuse me, as a distribution. X times x is x squared, but I also have to distribute x times 3. So I will get plus 3x. Now in the last problem, what we did was we did subtraction. And when it comes to numbers, we think pretty good with subtraction, although we're not nearly as good at subtraction as we are with addition. I prefer not to think of these as subtraction. It is subtraction. Okay? But I add better than I subtract. So what I encourage you to do is to change the signs and then add at this level. I'm going to change those signs and I'm going to add. So instead of this being positive x squared, it's now minus x squared. Instead of being plus 3x, it is minus 3x. Now what happens when I add? What happens to the x squareds? These cancel, don't they? That whole term goes away. What is 5x plus negative 3x? All right, I am going to bring down the next term, just like we did in regular division. The next term is going to come down, so I will get minus 7. And I start the process all over again. What do I multiply this x by to get 2x? And not only 2, also remember you need to think about the sign. So it's going to be a plus 2. So x times x, or 2 times x gives me 2x, and 2 times 3 gives me plus 6. Now, once again, I am going to change the signs, and I'm going to add. So this is now minus 2x and minus 6. So when I add, the 2x's cancel, and I get minus 7 plus minus 6. I get minus 13. Now, how do I write a final answer here? My final answer from this division is x plus 2. That is what is up here above the line. Now, I'm going to do plus minus 13 over x plus 3. If you do it with a plus, then it doesn't matter what sign the remainder comes out. So I've taken what was left and I've written it as a fraction again. Okay? Let's see what happens in example 3. Oops, example 3, down here. Here we go. I like to try to hide division problems on you. How is that a division problem? The negative 1 means that term belongs in the denominator. So this problem really is 4x cubed minus 6x squared plus 6 over 2x plus 3. All right, I can begin the process. Now the first term is 4x cubed. Now there's a secret here that we have to learn to put into our problems. Every term must be represented. Okay, let's start with those words here. Every term Now, what I mean is, x cubed is my biggest exponent. So I must have the x cubed and everything below it in the problem. I must have an x squared term, I must have an x term, and I must have an x to the 0 term, which is the number part. I must have every term. If one is missing, you fill with a 0. So if a term is missing, you will fill with a 0, like 0x, or 0x squared, or whatever it is you're missing, and you might miss more than one. So when I look, I have x cubed. The next term I'm looking for is an x squared. Do I have one in the problem? The answer is yes. I have minus 6x squared. Now I need an x term. Do I have one? No, I am missing that, so I am going to fill with a 0x. This is what we call a placeholder. That's a placeholder. And then I have my constant term. So when you miss a term, you will fill it with a placeholder. Now, I filled this part with the placeholder, but you can also put placeholders over here if you need them. If there's a term missing here, put a placeholder in it. You can add placeholders in both locations. Adding the placeholders makes everything line up beautifully. They're not required, but you will find that you will get more correct answers by doing placeholders because everything ends up in the correct location. All right, so let's ask, 2x times what gives me 4x cubed? I need a 2x squared, don't I? So again, distribute. This is now 4x cubed, and 3 times 2 is plus 6x squared. Now this is why it's so critical to think about changing the signs and adding. Because a lot of you would get this part of it wrong here with the 6's. Looks like 0, doesn't it? Change the signs and add. These cancel, but this gives me minus 12x squared. I bring down the next term. And I repeat the process. What do I multiply 2x by to get minus 12x squared? A minus 6x, don't I? Minus 6x. So that gives me minus 12x squared minus 18x. Change the signs and add. So I get 18x. I still have more terms. I bring down the next term. Go another round. I need to multiply 2x by plus 9. Always think about the signs. So this is 18x plus 27. Change the signs and add. So I get minus 11? 21, thank you, 21. As my remainder. So how do I write my final answer? My final answer is 2x squared minus 6x plus 9 plus negative 21 over 2x plus 3. All right, let's look at the next example. Let me just kind of back up a little bit. You know, adding and subtracting are opposites. One undoes the other. What undoes multiplication? Division. When I ask you to factor something, what I am really asking you to do is to create two things that if I multiply them together, I get the original, right? That's what factoring is all about. What two things, when I multiply them together, gives me what I started with. Factoring is division. You are doing division without actually physically dividing. Now, you can see that real quick if I ask you, what are the factors of 35? What two numbers multiply to give you 35? You're going to get the factors are 5 times 7. Now, you didn't physically divide. Can you divide? Sure, I can do 5 goes into 35 and get 7. 5 and 7 are the factors of 35. So when I ask you to find the factors of something, I am asking you to do division without having to do necessarily all this complicated stuff. You wouldn't want to have to do all this long division every single problem, right? It would take you a while. That's why we teach you other kinds of factoring first, so that we can go quicker. Now, I'm going to take a side step here. If I asked you to factor x cubed plus 1, that's something we should all know how to do, right? We taught you that pattern. That pattern should be x plus 1, x squared minus x plus 1, right? So, let's keep that in mind. I'm going to leave that on the board. Let's leave that aside. I asked you to factor that. All right, the next problem here, I have a division problem. I'm going to just start the same way we always start, x plus 1. And I will get x cubed. I need every single term. Do I have any x squareds? So I need to add a fill or a placeholder. Do I have any x's? Nope, I need another placeholder. Do I have any numbers? I have the plus 1. So now we are doing division. So x times x squared gives me x cubed. X squared times 1 gives me x squared. Notice the x squared is lining up underneath the x squared column. Change the signs and add. So I now have minus x squared. I bring down the placeholder. Do it again. Now I need to have a minus x, don't I? So I get minus x squared minus x. Change the signs and add. So I now have x. bring down the next term. X times 1 gives me X. 1 times 1 gives me 1. Change the signs and add. What happens? What do I end up with? 0. Now, when you get a 0 remainder, hey, it's really saying, guys, you should have factored me. Okay? You should have been able to factor me. But maybe I missed it. Maybe I missed it and I did the whole thing. Now, on these problems, what happens is the answer times what I divided by. If I multiply those, I get back to the original problem. That's what division is all about. This had been 35. This was 5. This was 7. 7 times 5 gave me 35. X squared minus x plus 1 times x plus 1 will give me x cubed plus 1. So what is the answer here? The answer here is x squared minus x plus 1. Now there's my answer. Now, how have we factored? If I take this answer with this, compare these two. What do you see? Okay, so factoring was division. You divided by this to get this. That's what factoring is all about. It's division. That's why it's going to be a tool that we're going to use when we come back after the first of the year.